Thank you. Good afternoon. I'm Simone Sergi. I will present now my research activity of the last year, named Cooperative Techniques for Wireless Communication Arranging. During the last year, I've worked on two main topics. The first one concerning the study of cooperative communication techniques for wireless network suitable to crisis management. And the second was about the investigation of a clustered arranging technique for indoor localization. With regard to the communication network for crisis management, our goal have been to develop a network able to satisfy these basic requirements. We want a full independency of the network on other infrastructure and rapid deployment capability. Moreover, we need support of a variable and potentially large number of users, as well as low latency and heterogeneous application. We also want low power consumption transmission techniques and at the same time high reliability in data communication. So the developed network ground on the following key factors. It is a fully ad hoc wireless network, so it employs local communication only and multi-hop routing in order to obtain fully connected networks. Cross-layer routing with cost metric based on residual resource have been implemented. This means that the routing process ground on some physical layer parameters that are residual energy, following the idea that it is better to make a transmission exploiting a terminal with a higher power availability, and residual transmission bandwidth. In this case, it is better to establish a link in a spatial zone with lower spectral occupancy. For the multi-user management, an orthogonal frequency division multiple access solution has been proposed, since it allows an easy dynamic assignment of bandwidth among the active user. All the former factors have twofold goals, that is ensuring the minimum capacity required by an application and at the same time minimizing the resource utilization. In order to achieve both high reliability and low power consuming transmission, the physical layer of the proposed networks ground on the cooperative diversity concept. This means that several terminals could at first acquire the same information and then cooperate in order to transmit it toward the receiver. To implement this transmission schema, suitable transmission techniques are needed. In our proposal, we use two distinct solutions based on space-time block coding and single carrier transmission lesson diversity. It has to be noted that in OFDM system, these techniques can be employed on a subcarrier by subcarrier basis. In this figure, you can see the performance level that can be achieved by our proposal. You can see the large performance gain achievable exploiting the cooperative techniques that have been proposed instead of a simple multiple communication, and how the proposed cooperative scheme are robust against carrier frequency offset in the network nodes. The second topic I have working on is indoor radio localization. The main goal of a radio localization system is discover the spatial location of a node with respect to a small set of fixed and no-located anchor. This is a problematic task in an indoor environment, mainly due to the heavy impairments of the indoor radio channel, like multipath propagation, deep fading, and propagation obstruction. This is why the ranging accuracy is generally very limited in this scenario. In order to overcome this fundamental limitation, we have proposed a clusterized approach to the ranging problem. So the basic idea is exploiting a set of measurement taken from different nodes that are collocated, that are neighboring, perhaps in the ear of the anchor, in order to improve the accuracy of one of them. For this purpose, two clusterization algorithms have been proposed, named variance-based clusterization and coarse distance-based clusterization. But now, for the sake of brevity, we cannot go into detail into these two proposals. In this figure, it's possible to see the large accuracy enhance gain that can be achieved with our clusterizing solution with regard to the traditional single node ranging. The simulation has also shown how the ranging accuracy is proportional to both the cluster size and the node density in the environment. In conclusion, in the last year I've worked on two main topics. The first one concerning communication network for crisis management, and within this project a design methodology for the development of an OFDMA-based wireless edge ad hoc networks has been proposed. Moreover, a novel cooperative communication schema have been studied, and some analytical methods for evaluating the symbol error probability for the proposed schema have been developed. About the second research topic, that was the clustered ranging techniques for indoor localization, a novel approach to the wireless ranging problem in indoor scenario has been proposed, and two different clusterization algorithms have been proposed. These are the publication, and with this I have ended. If you have some question.
No more questions. So thank you very much, and thank you very much to our colleagues of the e-learning area that assisted us in this web TV, wonderful web TV program of our D-Day. Now everything is over, just for the transmission, and next week we will have the videos on the ICT school portal. So you, especially you, will see your interpretation of your research activity. Thank you very much.